A 300-ton transformer, longer than a Boeing 747, crawling through narrow mountain passes. Or a submarine. Yes, an actual submarine, being hauled across land on 38 axles. These aren't science fiction. They're real transport operations happening right now, and you won't believe how they pull them off. The world of extreme transport is about to show you what happens when engineering meets impossible challenges. Let's take a deep dive into the world of extreme oversized trucks. Let's start with something truly massive. The Union Pacific Beast at Byer Canyon, Colorado. 9 locomotives, each weighing 200 tons, pulling 164 rail cars through terrain that would make mountain goats nervous. The combined horsepower? Over 39,600. That's like 400 sports cars working together. When this train moves through the canyon, the ground literally trembles. The lead locomotive can be entering a tunnel while the last car is still 2 miles back, creating a symphony of steel and power that echoes through the mountains. A massive reactor en route from Lithuania's Klaipėda port to the Mažeikiai oil refinery became immobilized on a gravel road. The reactor became stuck just a few hundred meters from a designated rest area in Erlenai village. Due to its sheer size and weight, transporting the reactor presents a unique logistical challenge. 1,500 tons, this colossal piece of equipment requires not only a meticulously planned route, but also specialized vehicles capable of navigating Lithuania's varied terrain. When it got stuck on the gravel road, it highlighted the immense coordination needed for such projects, as even a single delay can cascade through the entire schedule. To counter the difficult terrain, special metal sheets were brought in from the sea freight company Bega and carefully laid along the road's edges, providing added support for the heavy load. Crews remained on high alert, as any miscalculation could mean additional setbacks, adding even more complexity to an already difficult journey. The Caterpillar 793F mining dump truck delivery redefined what's possible on public roads. This behemoth can haul 250 tons of material in its bed. Imagine 50 full-grown elephants riding together. But moving the truck itself, that required splitting it into 6 major components, each needing its own specialized trailer. The largest piece was so wide that road signs had to be temporarily removed along a 200-mile stretch. The transport team needed 45 support vehicles, including police escorts, power line lifters, and structural engineers checking every bridge along the way. On a quiet June night, travelers along Denmark's E45 highway witnessed something extraordinary. An 88.4-meter wind turbine blade, the world's longest, making its historic debut journey across Danish roads. Departing from LM Windpower's Lunderskov factory at precisely 9:45 p.m., this enormous cargo embarked on a 218-kilometer trek to Aalborg, where rigorous testing awaited. For bystanders, the sight was nothing short of awe-inspiring, but for Koos van der Zee, Blade Transportation's senior manager, it was the culmination of 9 months of meticulous planning. Every detail of this transport was crafted with precision. Entire teams prepared to remove guardrails and signposts, ensuring the blade's safe passage, sometimes with only 3 centimeters of clearance beneath bridges. As the blade stretched nearly 100 meters down the road, onlookers lined streets and bridges, cheering as this marvel of engineering navigated its way through. It was a flawless journey, made possible by seamless coordination between LM Windpower, local authorities, and dedicated teams, leaving a powerful image of teamwork and innovation in heavy transport. Wind turbine blade transport operations take precision to another level. These 58-meter monsters are longer than 5 city buses lined up end to end. The special transport cradle they ride in costs €2 million alone. It can tilt the blade up to 60 degrees, rotate it 360 degrees, and lift it clear over obstacles. One transport team in Germany had to remove and replace 32 traffic lights, then put them all back the same night. The precision required? Millimeters. One wrong move and you've got a €500,000 blade turning into very expensive splinters. The Hitachi ZX excavator transport shows us why even experienced drivers get nervous. At 67.5 tons and 13.2 meters long, it's basically a building on wheels. The transport team spent 3 months planning the route, using satellite imagery to measure every turn. They had to calculate load distributions down to the kilogram, considering how weight shifts during turns. Special sensors monitored ground pressure at 16 different points, feeding data to computers that adjusted the trailer's hydraulic suspension 100 times per second. The U-17 submarine transport broke every rule in the book. A 450-ton war machine, designed for underwater travel, suddenly needed to cross highways and bridges. The solution? A transport vehicle with 152 wheels, each independently steerable. The hydraulic system used enough fluid to fill 3 backyard swimming pools. When it crossed bridges, the weight had to be distributed so precisely that no single square meter received more than 12 tons of pressure. The entire operation cost more than building a new submarine would have. But sometimes the most impressive transports are the ones that look the worst. A construction site is shattered as a colossal reactor vessel, the beating heart of Belarus's first power-generating nuclear unit, arrives. This isn't just any delivery, it's the result of a carefully orchestrated 2-month journey. Built by Atomash's Volgodonsk branch, this 330-ton behemoth stands at an impressive 13 meters, with a diameter of 4.5 meters, and is engineered to hold the reactor core, an elliptical marvel of engineering. But moving something of this scale isn't simple. First, it was loaded onto heavy trucks and driven to the Semlyansk reservoir. Then, it was floated along rivers to Veliky Novgorod, only to be hauled again by rail on a specially designed transporter, inching its way to the construction site. This is extreme transportation at its finest, a testament to human ingenuity and engineering precision. Modern transport innovations keep pushing boundaries. The Komatsu PC1250 UHD excavator moves showcase this perfectly. This machine can tear down buildings, but moving it requires taking apart its 40-meter boom system into 8 sections. Each section needs special cradles that cost 50,000 euros to build. The transport team uses GPS guidance accurate to within 2 centimeters, ensuring perfect placement on specialized trailers. That 380 kilovolt transformer transport? It rewrote the rulebook for heavy hauling. 3 hours for 3.9 kilometers sounds slow until you understand why. The transformer's magnetic field was so strong it could disrupt navigation equipment within 50 meters. The transport team had to use old-school surveying techniques, with people physically measuring distances with tape measures. The 81-meter convoy needed roads reinforced with steel plates every 10 meters. Just preparing the route took longer than the actual transport. Even vintage equipment presents unique challenges. That 1950s excavator move turned into a history lesson. The machine's steel, manufactured using post-war techniques, had different stress points than modern equipment. The transport team had to bring in a metallurgist to identify safe lifting points. The excavator's old hydraulic systems contained fluids that haven't been manufactured since 1960. One leak could cause an environmental hazard, so they wrapped the entire machine in a special containment system. Innovation never stops in this industry. New self-propelled modular transporters, SPMTs, can move loads up to 15,000 tons. That's like moving the Eiffel Tower. These machines look like giant mechanical centipedes, with hundreds of wheels all working independently. Computer systems monitor 18,000 data points per second, adjusting each wheel's height and angle to keep the load perfectly level. They can turn 360 degrees while carrying the weight of a fully loaded cargo ship, making them look like they're defying physics. The industry keeps evolving. New materials like carbon fiber reinforced polymers are making trailers stronger and lighter. Artificial intelligence systems now calculate routes considering thousands of variables, from weather patterns to traffic flow. Electric drive systems are appearing in heavy transport, promising quieter, more precise operations. Right now, somewhere in the world, transport teams are planning the next impossible move. Engineers are designing new systems, pushing the boundaries of what we think possible.